Once we know how to find the slope of a line, given either its graph or the function notation information that we have in example 6, which is similar to what we had in example 4, we can use that information to construct the full equation for our line or construct the entire function. To start off in example 5, we can choose any nice pair of coordinate points. We'll choose 1, 3 and -3, -5. Notice that our line is increasing, so whatever we get for our slope should be positive. If we get a positive value, we're on the right track. Taking the difference of our y values, we'll get -5 minus 3 over the difference of our x values, which would be -3 minus 1, which will give us -8 over -4, or 2. That value is positive, which matches the picture that we're looking at, and also tells us that we have an equation y equals 2x plus b. We're still missing that value for b, so we need to substitute something in for x and y. We know 2 different points that our line passes through, so we can use either of those pairs. Using the pair 1, 3, we can substitute in 3 for that value of y, and 1 for our value for x. And when we do that, we only have one variable remaining, which is b, or one unknown remaining, so we can solve for that remaining unknown. To do that, we'll subtract 2 from both sides, giving us 1 is equal to b. That tells us that our equation is y equals 2x plus 1. And since our function is the function s, to write that in function notation, this would become s of x is equal to 2x plus 1. In example 6, we're repeating that same process, just given different starting information. The first thing we need to do is translate this function notation information into our 2 coordinate pairs. This will be the pair x equals -3, y equals 9, and the coordinate pair -5, 19. We'll plug that information into our slope equation to get 19 minus 9 all over -5 minus -3. This will be 10 over -5 plus 3 once we take care of that double negative, or 10 over -2, which will give us -5. We're not looking at the graph again, but we can see that our slope is less than 0, meaning this is a decreasing line. And we have the beginning of our equation, y equals -5x plus b. From there, we plug in a value for x and a value for y, choosing either of our coordinate pairs. I'll plug in 9 for y and -3 for x, leaving us with one unknown to solve for. -5 times -3 will give us positive 15, so we'll subtract 15 from both sides to get -6 is equal to b. This means our linear equation would be y equals -5x minus 6, but our function is function d, so we would rewrite this as d of x is equal to -5x minus 6.